That's what's meant. So we're paying a lot of attention to this new subject. We see a lot of benefit in it. First for society, of course, because we think these new choice of transport offers will be safe, it'll be reliable, it'll help connect islands, countries and communities. It'll make it possible to reach remote areas that might not be so easy before. In a crisis, they could be used to deliver relief and medical supplies, and in more normal times, they can be used to deliver emergency help in the same way as we see with helicopter emergency medical services today. That's the first reason. The second reason is an environmental reason. These aircraft are electrically powered, so they're quiet, sustainable. We see them as complementing rather than replacing other forms of transport. And because they're new, they can really be designed with sustainability in mind. Economically, from a, let's say, a country point of view, they're going to improve connectivity. So particularly for, let's say, businessmen on a tight deadline, this will really save time. Okay, Singapore is super connected anyway. It doesn't take you long to get across Singapore, but if you're in a city like Jakarta, for example, a totally different story. And they also open up, so urban air mobility and also drones, the kind of its younger brother, open up the possibility of new business models. So in short, they'll improve trade and tourism. And the final reason, politically, if you think back to the early days of aviation, I think that it carried a lot of glamour. It's not really the case anymore. But these new flying machines, I think, bring a bit of glamour back into aviation. Brings a bit of cachet, and from a political level, I think they bring a positive image. So, for example, they can help promote the idea of a modern Singapore, or in Europe, for example, Paris, the Paris Olympics this summer. You'll see them flying around. They project a certain something. So, a quick explanation about what is EASA. You might not have necessarily heard of us before. Very simply, we're the European equivalent of CAS, the Civil Aviation Authority of Singapore. That's very simplified because nothing in Europe is that simple. So, as you can see here, our headquarters are in Cologne. We have an office in Brussels because the other EU institutions are there. And there are also EASA offices in Beijing, Washington, Montreal, because of the United Nations body for civil aviation, Panama, which covers Latin America and Caribbean, and of course the most important office, which is Singapore. So this slide shows the main things we do. In general, the logic is that EASA, as opposed to a national aviation authority, we do the things that it makes sense to do at a European level. So it makes sense to have one set of rules for all of Europe. That way, especially for aviation, flying between countries, same rules everywhere, that's simpler for everyone. If we talk about type certification, so these new products, as especially Derek will talk about later, to prove that it's safe, to type certify one is really, really expensive. So it makes sense to just do it once, and then it's good all over Europe. You don't want to have to do that separately in France, Germany, Spain, and so on. Yeah, and we don't, slight difference between us and CAS, for example, is we're not an air navigation service provider. So it's not 100% the same thing. We just focus on safety and sustainability. So now on to safety regulation. It's been said in the past that aviation safety regulations are written in blood. So there are many rules and requirements which, if you look at them, derive, unfortunately, from experience from a particular incident or accident. And as you can see, over time, fortunately, the level of fatalities from aviation has fallen. These days are different from the 1940s. The public will not accept an accident anymore. They will not accept a learning curve. Of course, the safest aircraft is one that stays on the ground. But we, as regulators, have a duty to enable industry because it benefits society, rather than shut it down. Our role within this ecosystem is to be the guarantor of public trust. So technology is usually the regulator's friend. So here we can see all kinds of technology that has come along the way to make aircraft safer. Here, now we're kind of entering into another dynamic because the pace of technology is moving faster and faster. And it's running faster than the rule-making progress. And that's not unique to aviation, but other sectors as well, such as artificial intelligence and so on. So this makes it even more challenging because the public has a very high expectation in terms of safety. And also there's a really less and less time and room to learn from experience, as mentioned. So the main challenges include safety and environmental protection, timely regulations, societal acceptance, and integration into the larger existing aviation ecosystem. And our mindset as regulators needs to evolve with that. We need to move from a traditional, prescriptive, compliance-based or like checklist approach to something more forward-thinking, performance-based, and we really need to think, we need to have a comprehensive understanding of these future operations and how these new entrants will fit in. Similarly, we also have a challenge because a lot of the people bringing these new technologies into the market, they're not from an aviation background. For example, drones manufacturers or something. I mean, might even be from Silicon Valley tech guys, and they don't have that aviation mindset and understanding. So we're having to develop new innovative approaches to regulation. So things like innovative test environments, we call them regulatory sandboxes, where these products can be demonstrated, tested kind of at a not a lower level of safety, but I mean away from, let's say, the general public, where we can sit in ways so we can build up confidence, we can demonstrate there's a safety case before this technology rolls out any further. Cooperation is a key success factor in this. There needs to be good cooperation between us, between the manufacturers, with the public, and also to enable this industry, there needs to be cooperation internationally, because industry would like to sell its products internationally. And Singapore is very good at this, sort of building up these cooperation frameworks, facilitating early engagement with the industry to share understanding, get ahead of the technology curve, and foster harmonization. So, as mentioned, the challenge surrounding the new modes of transport and new business models have to be considered in the context of the whole ecosystem. Please go ahead and read the slide there. So, I mean, there's a product, of course. The products have to be safe and increasingly have to be sustainable. But it's not just about the product, it's about the supply chain and other actors involved in making this a success. So, researchers, suppliers, leasers, manufacturers, aircraft operators, maintenance organizations, air traffic management, vertiport operators, standards organizations, all these parties have to be brought together. And of course, from a regulator's point of view, I'm an aviation regulator, but I have to start working with other regulators as well, such as municipal authorities. These products are going to be flying in and around the towns, so I have to start engaging with these stakeholders as well. Okay, so let's have a look at safety standards. So urban air mobility is totally new, so we can't rely on the existing certification specifications that you might use for your average Airbus or Boeing aircraft, for example. And we at EASA, we had a choice. We could kind of take the existing certification specifications for general aviation, light aircraft, for example, or helicopters, and kind of tweak and adapt them. Or we could have gone for something new to kind of really reflect this totally unique nature of these new products. So we chose to go for something new and created special conditions for vertical takeoff and landing aircraft. That's this SC VTOL you see up there. Electrical hybrid propulsion systems, that's the EHPS. And unmanned aircraft systems, that's the UAS you see up there. And just to give you a kind of insight into what's in this document, if you download it off the EASA website, this is what you'll find in there. So the different categories, what we expect in different terms of performance and requirements. The whole purpose of this really is to give manufacturers a kind of heads up as to what we, the regulator, are looking for to help them design their aircraft, because they know what kind of tests and barriers and hoops they will have to go through. So propulsion, fire protection, bird strikes, downwash, flotation, icing conditions. That slide is already doomed. Okay. But you get the idea. Of course, it's not just about design. We're developing a broader set of rules. The philosophy of the regulation is, is always to keep it proportionate. There's a much lighter regulation for lower risk operations, as you see here for drones. And the way it's done in EASA, we've split it into these three categories. eVTOLs, electric vertical takeoff and landing aircraft, urban air mobility, the vehicles we're talking about today. I'll focus on them now. There's something called Opinion 03/2023. I'll talk about that in a second, which will be voted on in February and will turn into a rule. So, yeah, that covers both unmanned and manned systems. It's key to point out, I think, for this new type of aircraft, we are going to be requiring exactly the same level of safety as for normal commercial air transport. So the same level of safety that you would expect when you get onto an Airbus, for example. So operators will require a safety management system and all the same factors in place. So this is an opinion, and as I said, it will be turned into a regulation very, very soon. And it's just one of a batch of regulations. This slide shows the expected evolution of industry over the coming years, if you look at the pictures. And this demonstrates in colour there. You can see these opinion, NPA, which is a notice of proposed amendments. These are just regulator terms for these different documents where we publish our draft rules, we allow people to comment on them, and then eventually these turn into regulations. interested and you want more detail, you can find them on the EASA website. You can even comment on them. You don't have to be European to comment on them. We really appreciate good ideas from wherever they come from. When these turn into regulations, they will pretty much impact the entire suite of existing regulations that we have. Airworthiness, production, maintenance, operations, airspace, aerodromes, and so forth. There's a regulation called Part IAM, so Innovative Air Mobility, which will come out and which will amend the existing air operations regulation, for example, to enable this regulation, to enable these new products to fly. For example, I think I mentioned earlier, HEMS, Helicopter Emergency Medical Services. This regulation will allow VTOL, vertical takeoff and landing aircraft, emergency medical services, so VEMS instead of HEMS. So that's just one part of the jigsaw. This is the kind of overall roadmap to urban air mobility. I'm going to talk about, sort of jump a little bit between topics just to give you a flavour of what kind of changes have to be put in place to accommodate these new services. You'll see there regulations on use space, sorry, that's urban traffic management. Vertiports is the kind of like the aerodrome or heliport for this new technology. All this is going to be rolled out over time. Just to explain the divergence of the arrow there, I told you that Europe was complicated. It's because of the division between what EASA does and what the member states does. So apologies for that, but you can see, the point is that you can see the flow from left to right there. So for those of you who really are interested in the way that the regulations will roll out, here's the latest planning. You'll see reference there AMCGM. I'll just quickly explain that. That's acceptable means of compliance and guidance material. The way that the regulation is structured in Europe is you have the kind of hard law. That's the regulation. When you think about regulations, that's what I'm sure you're thinking about. That's the law, black and white. We have a kind of level below that, which I call soft law. As I said, this guidance material, acceptable means of compliance. It's a little more flexible. So it's guidance. How do you demonstrate you meet the rule? Okay, this guidance material will explain in further detail. And the acceptable means of compliance means you can do it this way. But as a manufacturer, you're also free to suggest another way. It's good to have this detail buried in a more flexible level of regulation. It's easier for us to update, a lot faster for us to update, and that's good for manufacturers and so on, because, yeah, at the end of the day, we're interested in the performance, the safety. We don't really kind of care how they do it, as long as you can achieve those performance targets. So a particular topic, I mentioned vertiports earlier, which are like the airports or heliports. I won't talk about them much because Yun will go into far more detail. We had to similarly create new regulations for those from scratch, which had to be accommodated under our existing legal setup. Again, the logic is, yes, rules aren't yet in place, but companies such as Skyports need to have clarity on what else the regulator is going to expect. So it's useful for Skyports, it's useful for the civil aviation authorities in European member states, designers, urban planners, and so on. And they'll have to tackle issues that don't exist under the existing rules. So, for example, the firefighting of electric battery fires, or eventually when we talk about unmanned eVTOLs, who is it? There's no pilot. Who is it that calls the rescue services? All these things have to be accommodated for. And the way we go about creating these rules is very much collaborative. We gather the existing relevant stakeholders together, develop something that makes sense, usually based on the existing frameworks as a starting point, and then, as I mentioned earlier, publish the comments so that everyone gets their inputs and has their say. I was also saying something about our environmental protection, technical specifications. So this is basically to do with noise, really. People do not like noise. It was one of the kind of main, when we surveyed societal concerns, the top thing that people did not want is, or were worried about, was the disturbance of these aircraft. So we need to define how this noise is going to be measured. There are existing regulations in something called ICAO Annex 16. We took those, we've adjusted them, and we've kind of shown the manufacturers how it is we go about testing them, what we're looking for. So you can see here, for example, although this is a slightly old diagram, it explains the concept. Okay, what heights are we talking about? Where will we be putting our microphones? What noise levels are we looking for? Again, it's all about providing clarity. Airspace. Another important topic is how to control the airspace. So I mentioned urban traffic management, or U-space as we call it in Europe. We're now going to have these unmanned aircraft, so drones and eventually eVTOLs will fly unmanned, interacting in the airspace with normal aircraft, airspace users. And so this regulation kind of sets up how that's going to be done. A set of services will be provided to operators and ensure the necessary information and data can be exchanged. And by defining this in regulation, we can kind of harmonise the necessary conditions to prevent collisions between aircraft and mitigate air and ground risks. As you can imagine, if you have lots of these aircraft flying around, especially drones, it'll have to be very, very highly automated. And it's expected that this will be delegated to artificial intelligence, as it wouldn't be possible for a human air traffic controller to deal with that volume of traffic. So my colleagues at the EASA are looking at how artificial intelligence will contribute. We've developed a roadmap which basically talks about 3 levels. There's level 1 where the human is in control and the machine just helps. Level 2, which is more collaborative, the human and machine are kind of monitoring each other. And then level 3, which please don't expect for another 10 or 15 years at best, where the machine is autonomous. And the last topic I kind of wanted to present with the time I have available is this study we conducted on societal acceptance. So this kind of loops back to the big picture that I was talking about at the beginning. We can't implement this technology without the acceptance and trust of the people that we're trying to serve. So this study that we carried out surveyed European citizens, considered their opinions of different types of operation. So, for example, the delivery of cake is not quite the same. Wouldn't be considered by people in the same way as the delivery of medicine or blood, for example. Travel from the airport, all these different potential operations. I know that one thing that took my management by surprise when we got the results back from this survey was the level of public concern for the environment, by which I don't mean the noise, as I mentioned earlier, of these aircraft flying around, but their impact on wildlife, which is important because this could affect things like planning permission for your vertiport, for example. If you have a wildlife lobby group campaigning to the local mayor, your vertiport will not be built. So that closes my presentation. So I hope it gave you an insight into the regulator's perspective.